Hello, this is a demonstration of a correlation question from the Aqa S1 syllabus, and I'm going to use the June 2010 question 1 as a demonstration. So what's the first thing that we do in any question is we sit down and read it. Right, first paragraph, the weight, x kilograms, and the engine power, y brake horsepower, of each car in a random sample of 10 hatchback cars are shown in the table. So here's the table below, and that's our data. Okay, and it asks us, A, calculate the value of the product moment correlation coefficient between x and y. Okay, so product moment correlation coefficient, also known as Pearson's product moment correlation coefficient, on page 13 of the formula book. We can see what the calculation is, but it's usually known as R as its value, and we can actually find this out, its value, from our calculator. And our calculator will go through and work out this correlation coefficient, and what it's doing is it's correlating for each of these cars. We've got 10 cars, number 1, 2, 3, 4, 5, 6, 7, 8, up to 10, and for each one we've got a value of the weight. First one there, 1,196 kilograms, against the engine power here, 123 brake horsepower. So what this method does is it goes and calculates how well correlated they are. So we'd have a scatter diagram, and then we'd have the numbers, and we'd see how closely correlated they were. Okay, we can do this using our calculator. And here, if we went in here and went into our stats module, we can enter the data as the two lists. So the X list, starting with the 1196, goes into list 1, and the Y list, 123 onwards, goes into list 2. We then press graph 1. We can see here that the calculator has put on the screen a graph of, it's a scatter diagram of the points. In the X direction, we've got the X values. In the Y direction, we've got the Y values. If we go into the calc mode, and then X, because we're interested in our linear correlation between the two, we get this screen of all the linear regression figures. What we want from this is the R value, the product moment correlation coefficient, and here our R value is 0.195. So that's relatively easily answers the first question. R equals 0.915. Okay. Second part of this is to interpret your value. We've got a value above, that's the 0.195, in the context of the question. Okay, so in this case, we're always starting off one of these things. We're going to write one sentence, and this sentence always starts off, there is. And in this case, because we've got quite a high correlation coefficient, we're going to say that there is a strong correlation. But before we move on, we also have to describe whether it's a we could at this point, could be strong, it could be moderate, it could be weak, but here we've got strong because we've got a high value. Second part is we need to decide whether it's a positive or negative. So that value R is positive, so it's a positive correlation, a strong positive correlation, and then we've got to say between what? Between. Let's have a look. Weight, our X value is the weight in kilograms of the car. That's our X value. And the power, the engine power, brake horsepower, bhp. So here we go. bhp, and that's our Y value. So there is a strong positive correlation between the weight and kilograms and the engine power in brake horsepower. So that's pretty straightforward. So what we're going to do to make this to expand on this a bit more is I've got a summary for you, and this is going to go a bit more into the theory because that was so straightforward. Here we go then. Okay, so let's summarize where we are. Correlation. The Pearson product moment correlation coefficient, also known as PMCC, and usually written with the letter R. It's in the AQA formula book, page 13, and it is a formula that R equals SXY over the square root of SXX times SYY. Because they might give you a question where they give you those three figures and you have to work out R. Okay, now the correlation coefficient R has a range between -1 and +1, and if the value is positive, that means there's a positive correlation. Okay, and the most highly correlated positive correlation will be a value of R equals 1, and that would reflect a scatter diagram, a bit like I'm doing here with the green line, would have a positive gradient on it, positive correlation between the two. Okay. The other situation we can have is that there's a negative correlation. So we have a series of points here, which actually our correlation is taking us in a negative direction. Yep, so it's going down, it's got a negative gradient, so our R value is less than 0, the most extreme value is -1. Okay, we also got some terminology we've got to use, and what we're looking at here is we've basically got three terms to use for the strength of the correlation. So strong correlations probably between 0.5 and 1, moderate correlation coefficients between 0.4 and 0.8, and weak is between 0 and 0.4. So that'd be the first part. Then we have to say whether it's positive or negative. So positive, the R is a positive value. Negative correlation, R is a negative value. And we're going to end up by all these questions by writing a context statement, which is there is a strong, in this case a strong, but in other cases could be strong, moderate or weak. That'll be your first choice, and your second choice is positive or negative correlation between X and Y. So there you are. That's a quick summary of it. I hope that's of use to you, and thank you for watching.